Hello everyone. Today we are going to discuss the second part of Introduction to the Metrology. Myself, Mr. Bipin Patil, lecturer, Department of Mechanical Engineering at Sharad Institute of Technology, Polytechnic, Yedrav. Our all programs are accredited by NBA. So let us see what we have studied in last lecture.
So, at last lecture, we have studied what is metrology, definition of metrology. Metrology is a branch of measurement, or it is the science of measurement, and second, objective of metrology. Their categories, their types, scientific metrology, industrial metrology, legal metrology, deterministic metrology, then need of inspection, and important questions as per the university or board point of view. So let us see the today's lecture content. Today we are going to study the characteristics of measuring instruments. There are two types of characteristics of instrument. First is static, second dynamic. Then errors in measurement. In every measurement there is an error. So today we are going to discuss what kind of errors actually include in our measurement. Then sources of errors, types of errors in measurement, and important question as per the board point of view. So let us start with our content. So coming to the first content, characteristics of measuring instrument. So as I discussed earlier, there are two main characteristics of measuring instrument are static characteristics and dynamic characteristics. So today we are going to discuss only about the static characteristics of measuring instrument. There are so many static characteristics of measuring instrument. First of all, we are going to discuss about the accuracy. So accuracy may be defined as the closeness of measured value with the true value, or we can say it is a degree of closeness. For example, if true value of component is 10.25 mm and measured value are 10.24 mm, 10.18 mm, 10.20 mm, then they are not accurate as compared to 10.25 mm. So accuracy is a very basic characteristics of a measuring instrument, and every instrument should be accurate. So coming to the precision, what is meant by precision, or what is the difference between accuracy and precision? So let us see what is the definition of precision. So it is mainly concerned with the measurement. It may be defined as the degree to which an instrument gives repeated measurements of the same standards. It exists only when a set of measurements are carried out for same quantity under similar conditions by same operator, or we can say it is a repeated measured value of a measurand. For example, if true value is 25 mm, readings are 25.01, 25.02, 25 mm, 24.99, 24.99 are said to be precise, as variation in reading above in the readings or below the mean value 25 mm are very small. So comparing the accuracy versus precision, here the image is showing the shooter shooting to the target and achieving his accuracy as well as precision. So in first image, or we can say at upper left corner, shooter's accuracy is low, also his precision is low. And at lower left corner, or we can say second image, accuracy of shooter is high but the precision is less or low. Here at the third image, or at upper right corner, shooter having low accuracy but his precision is high. And at the last image, or we can say at lower right corner, accuracy as well as the precision of shooter is high. Same, the instrument or the measuring instrument should have good accuracy as well as precision. So let us see the basic difference of accuracy and precision. Closeness of measured value with the true value is called accuracy. Repeatability of measuring process is called precision. Coming to the second difference, accuracy is related to true value, Precision is related to average value. Accuracy is concerned with single value. Precision is useful for a set of measurement. Costlier to achieve great accuracy, but easier and cheaper to achieve precision. For example, if true value is 10 mm, 9.99 mm is more accurate than 9.98 mm. Here, precision, for example, if true value is 10 mm, reading 10.01, 10.02, 9.99, 10, 9.98 are precise as variation in the readings above or below the mean value 10 mm are very small. It is all about accuracy and precision. So every measuring instrument should be accurate as well as precise. Coming to the next characteristics, sensitivity. So the ability of measuring instrument to detect small variation in a quantity being measured is known as sensitivity. High sensitivity may lead to the overshoot, and low sensitivity would result in delay in measuring response. So every measuring instrument should be moderate sensitive. Coming to the next characteristics, readability. The case with which the reading of measuring instrument can be read is known as readability. Here, very closely spaced lines in a linear measuring instrument may lead to poor readability. But this problem can be overcome by providing adequate magnification arrangement. Image showing that a dial indicator having slow close place scale engraved in it, but it leads to error in measurement. So it is having poor readability. Coming to the next characteristics, traceability. The property of result of a measurement or the value of standard whereby it can be related to references, usually national or international standard, is known as traceability. Traceability can be used to calibrate the measuring instrument. Let us discuss the next characteristics of a measuring instrument, calibration. The calibration is process of framing or checking scale of an instrument by using some standards. To maintain the accuracy of instrument, they need to be calibrated regularly after using it for a specified period of time. So every instrument should be calibrated to meet its reliability as well as its accuracy. So image showing that a pressure gauge being calibrated using standard hydraulic digital pressure gauge. Let us see the next characteristics of a measuring instrument, reproducibility. As the name indicates, every measuring instrument should possess reproducibility characteristics. So coming to the definition of reproducibility, the closeness of agreement between the results of same quantity by different observer by different method with different instrument under different condition is known as reproducibility. Coming to the repeatability characteristics, the ability of measuring instrument to repeat the output reading consistently when the same quantity is measured number of times under same conditions, that is identical condition, same observer, same instrument and same environmental condition. Here the image showing at every time the head of nut and bolt measured by the vernier caliper, and vernier caliper should show the same reading with different observer, different conditions and different instrument, that is called reproducibility. And when that vernier shows exact same reading number of times at same observer, same instrument and same environmental condition, that is called repeatability. So coming to the errors of a measurement, so let us see the errors in measurement. So earlier we have discussed the all static characteristics of a measuring instrument. We have seen accuracy, precision, sensitivity, calibration, traceability, repeatability, reproducibility, etc. So these are the most useful characteristics of a measuring instrument, but there is no such a measurement which gives the exact value. So always there is a error is existed in measurement system. So let us see what is mean by error. Coming to the definition of error, error may be defined as the difference between true value and measured value or indicated value. Mathematically it is shown error is equal to true value minus measured value. So keep in mind that no measurement is exact. Every measurement contains error. The true value of measurement is never known. The exact error present is always unknown. Before going to discuss about the types of error, let us see the various sources of errors. So first of all, the source of error, defects in instruments or improper design. If the design of an instrument is improper, it may lead to error. Second, calibration of instrument. Third, error due to measuring forces of an instrument. So if the force of a measurement is improper, it may also occur the error. Fourth, error due to material properties of an object. Fifth, error due to surface finish of an object. Sixth, manual adjustment of an object. Seventh, observational error or human error. We can also call as a parallax error. And last one, error due to shape and size of an object. So let us see what are the types of errors. As we have discussed earlier, there is no such a kind of measurement in which error doesn't exist. So in each and every measurement there is a error. So let us see which kind of error exists in a measurement system. So let us see the major types of errors. First, systematic or controllable errors, and second, random errors. Systematic errors are further classified into different types, and also the random error is having characteristics of it. So let us see the types of errors. Let us see the first type of error, systematic or controllable errors. So systematic or controllable error are in the form of experimental mistakes. So following are the types of systematic or controllable errors. First, alignment error. As the name indicates, alignment error comes due to misalignment. Second, environmental error. Third, support error. Fourth, contact error. And last one, reading error. So let us see in brief what is meant by alignment, environmental, support and contact and reading errors are. Coming to first systematic error, that is alignment error. Let us see the image of an alignment error. So alignment error is based on the principle of alignment, or that is also called as a Abbe's principle. It states that the line of measurement of a component to be measured should coincide with the measuring scale with the true or actual dimension being measured. The kind of error is caused due to misalignment of measuring scale with true actual dimension being measured. As the image shows here, image A showing that the correct method of measurement, whereas the image B showing that wrong method of measurement. The steel rule is having theta angle which is not coincide with the component's neutral axis. So such kind of errors occurs when measurement done by the steel rule or micrometers. After the alignment error, let us discuss about the environmental error. Environmental errors are mainly caused due to effect of surrounding temperature, pressure, humidity, etc. on the measuring instrument. As the temperature plays an important role while measurement, all metrology laboratory and standard rooms are maintained at 20 degrees Celsius. External influences like magnetic or electrical field, nuclear radiation, vibration or shock, periodic or random motion, etc. are also leads to the error. As the image shows the dimensional laboratory in which the temperature of a measuring laboratory kept at 20 degrees Celsius. due to which its normal temperature, pressure and humidity are get controlled. Coming to the next controllable error, that is support error. As the image shows, in image A, B and C, there are three types of a support system. So let us see how exactly the support error occurs. In case of heavy long bar at the time of support, they may cause bending due to self-weight or external load. As the figure A and B shows two extreme cases of bending in which supports either at low distance or high distance. The error produced due to improper support error. To reduce such type of error, the distance between the point is kept 0.577 of the total distance of a bar L as shown in figure. So, keeping the proper support distance, we can avoid the support errors. And coming to the next error, contact error. Contact error produced due to improper contact between component and measuring instrument. For example, consider a ring as shown in figure whose thickness is to be measured. If the jaw of instrument are placed as shown in figure, then an error is produced due to improper contact only. That image is showing we have to measure the thickness of a component, but the anvil or the jaws of an instrument not touching the internal arc of that component. So sometimes application of excessive pressure may causes the error due to elastic deformation of a component. So such kind of errors are called contact errors. Going to the next error, that is reading error or parallax error. Let us see the reading error. This is a last type of a controllable or systematic error. Also it is called as a reading error or parallax error, or we can say it as a observational error. Image showing that there are three eyesights taking the reading of a same point which is exactly at 4.8 centimeter. So let us see how exactly such kind of errors occurs. At the time of taking a reading on a scale, the position of observer plays very important role. If the position of observer is improper, then it produces error in measurement. To reduce such kind of errors, we can use digital scale, we can use mirror readouts, or we can set a proper eyesight to taking the observations. So these are the basic types, or we can say the basic errors of a systematic or controllable error. Let us see what exactly the random error and what are the characteristics of random error. Coming to the last major type of a error, that is random error. As the name indicates, it is random, so it is unpredictable and fluctuating. So let us see how exactly the random error occurs. A random error occurs randomly and they cannot be determined. The errors are generated due to number of unpredictable and fluctuating causes. For example, vibration, friction between the surface, backlash in instrument, fluctuation in power supply, etc. So following are the characteristics of random error. Let us see the characteristics of random error. First, these are caused by friction. Second, these are variable in magnitude. Third, it cannot be announced by statistical analysis of the measurement data. So this is all about today's lecture. We have discussed about characteristics of measuring instrument. We have seen accuracy, precision, calibration, readability, traceability, etc. We have discussed about sources of errors. We have discussed about types of errors in brief. So this is the upcoming lecture's content. Let us see factors affecting on accuracy, factors for selection of instrument, precautions for using an instrument, and finally we are going to discuss least count of measuring instrument. Let us see the important questions as per the university or board exam point of view. So, first question, define accuracy, precision, which will asked in exam for 4 marks. Second, difference between accuracy and precision. Define term reproducibility, repeatability. Fourth, explain the term calibration. Fifth question, what are the sources of errors in measurement? And sixth question, list the major error in measurement and explain any one in detail. So this is all about today's lecture. If any queries or doubts, ask in comment below. Thank you. Thank you very much.